Ladies and gentlemen, we're going to do some more examples here. Chain rule examples, a video I promised you guys. So, okay, let's see what we can get here. They're going to give you a function, maybe 3x minus 7 times tangent of 5x. So we're going to have to find f prime. So we're going to differentiate 3x minus 7 times tangent 5x. So we're going to look at this here. This is going to be product rule. Corey Seager just hit a home run. Yeah, sorry. First function, second function. So we're going to do product rule here, ladies and gentlemen. And so we're going to take the first function outside. We're going to differentiate the second function. Plus that second function. And differentiate the first function. Here we go. Green, green, orange, orange. Okay. Now, what you'll see here for the first part is actually chain rule again, because we're going to have to differentiate tangent. Derivative of tangent is secant squared 5x now times the derivative by chain rule of 5x. So just like we talked about this morning, I'm going to note here that if they give you the function tangent of anything, its derivative is secant squared of that times the derivative of that inside function here. So here's the picture of what we're doing. And now you might say the derivative of 5x is just 5 here. So keep in mind all of these functions here for that first part of the product rule. And so now we have the derivative of 3x, which will just be 3. So, okay, so we're going to have to put all of this together. So we have, if we're careful here, 3x minus 7 times secant squared of 5x times 5 plus tangent 5x times 3. Now, we typically switch the order, and we'll write it down this way. F prime x, we put the constants first, and then maybe some polynomials followed by some trig functions. Put a constant first here, and you get tangent 5x. And there you go. And there it is, ladies and gentlemen. This is f prime, where we get to use product rule. (5x plus 4 to the third power). And let's do this. 2x minus 7 to the fifth power. So we look at more examples here of chain rule. Okay. Derivative of 5x plus 4 to the third power times 2x minus 7 to the fifth power. Okay, again, you're going to have first function here. Oops, let's go back. First function here. Second function. So you're going to pull out the first function, 5x plus 4, to the third. Then you're going to differentiate 2x minus 7 to the fifth. Okay, this is the first part of the product rule. So maybe we should write that down. As well. Don't forget now, we're going to add the second function, which is 2x minus 7 to the fifth power. And we're going to differentiate the first function, 5x plus 4 to the third power. Okay, so let's look at the colors here to make sure we're doing everything correct. Here's the first function. Differentiate the first function. Here's the second function that you differentiate, and then you pull out that second function. Okay, we're looking at product rule here. And now I'm going to give you guys another note, something we talked about earlier today. You have a function to a power. The derivative by chain rule is, this is kind of like the power rule version for chain rule. So that's the chain rule portion. I say that because here this portion becomes 5, 2x minus 7, 5 minus 1 is 4 times the derivative of 2x minus 7. Remember, this here is the inside function. So you're doing power rule, and then you're taking the derivative of that inside function. It's just we haven't taken that derivative yet. This derivative here will be 2. So be careful here. We have this information to consider. And that's just for the first derivative. Over here now, power rule says 3, 5x plus 4 squared times the derivative of 5x plus 4. Okay, I'm going to move that out of the way. And your derivative of 5x plus 4 is just 5. So I'm going to put in gray here the terms we have to use here. So we're going to use everything here. Here's what we're going to use. This is your answer here. We got this term. Don't forget 5 times this term plus this term, 3. Okay, you guys see what's going on? We got a lot going on there. So here's what this becomes. 5 times 2 we know is 10 here. So we can write 10. Well, let me do every detail. (5x) plus 4 cubed times 2 times 5 is 10 times 2x minus 7 to the 4th power plus, now we're going to say 2x minus 7 to the 5th power. And that's going to be times 3 times 5. I'm going to say times 15. And don't forget you have that 5x plus 4 squared. So double check that we're multiplying the right constants together. You got to really keep track of everything. And now I'm just going to switch the order. I'm going to put my constants out first. You have 5x plus 4 to the 3rd power. And you get 2x minus 7 to the 4th power plus 15. And I'm going to do something here. I'm going to be consistent. 5x plus 4 squared, 2x minus 7 to the 5th power here. So you say, what do you mean by be consistent? Notice I put this term here first, right? The 5x plus 4 followed by the 2x minus 7. So that's what I mean by being consistent. So that derivative is the constant 10, 5x plus 4 to the third power, 2x minus 7 to the fourth, plus 15, nothing. Dodgers winning. What just happened? Oh, Bellinger got an RBI. All right. Anyway, I'm going to stop right there. I could do more by factoring. Anyway. I'm going to leave it like this for now, ladies and gentlemen. Could I do more? I could, but I think I'm just going to focus on chain rule, right? We're just going to focus on working our chain rule. F of x is maybe x to the fourth plus x cubed minus 2x squared plus x plus 3 to the fifth power. We're going to focus on chain rule, ladies and gentlemen. And here, I want you guys to note that we have a function to a power that's n. Here we go. This is really power rule again, right? So we have the inside function here. There it is. So we have a power. So this is the idea behind power rule. So you guys can see that maybe a little better. And the chain rule portion, don't forget the chain. So this will be n here, and then we take the derivative of the inside function. That's how you do this. So f prime x becomes 5 x to the fourth plus x cubed minus 2x squared plus x plus 3 times 4. Now I'm going to have to move this like always. And then this is going to be times the derivative of x to the fourth plus x cubed minus 2x squared plus x plus 3. And now we differentiate here by using properties of derivatives. 4x cubed plus 3x squared minus 4x plus 1, ladies and gentlemen. So keep track of what's here. We have this term times this term. Okay. F prime x, 5 x to the fourth plus x cubed minus 2x squared plus x plus 3 to the fourth power, and then 4x cubed plus 3x squared minus 4x plus 1. Yeah, undo this. And there it is. These are additional examples of using chain rule. Okay. F of x is the square root of maybe x squared minus 9 here. Here's what I'm going to say. You want to think of this as x squared minus 9 to the 1/2 power. So as you can see, if we have here, a base to a power, that's exactly what we have again. In other words, you have this power here, right? Power is 1/2. You use power rule, but you use a chain rule version of that. So don't forget to take the derivative of the inside function there. Okay. So f prime x is the derivative of x squared minus 9 to the 1/2. Now power rule says this is 1/2 x squared minus 9 to the 1 minus 1/2. And we differentiate the x squared minus 9. So this will be 1/2 x squared minus 9 to the minus 1/2. And you differentiate x squared minus 9 and you get a nice 2x. So that's the chain part times that 2x. So the 2's will cancel. And you'll have an x over x squared minus 9 to the positive 1/2. Okay, so the final answer here is going to be f prime x is x over the square root x squared minus 9. So, here's kind of an interesting question as well. F of x, we'll say 5 minus x cubed to maybe the 4/3 power. So again, I'm going to note that this is going to be the power rule version of chain rule. Right? I have a power. Here's the derivative. Notice, like the past problem, you got that inside function here, and it's raised to a power. So it's n, here's n, and here's the inside function. Okay, let's get to work. F prime x becomes 4/3 5 minus x cubed, 4/3 minus 1 times the derivative of 5 minus x cubed. All right, I guess what's the score? Is that 15? They scored 3 runs? 15-0, ladies and gentlemen. Dodgers are winning. It's about time. Here's my derivative, minus 3x squared. Is that right? And don't forget here to do some arithmetic. Okay. F prime x becomes 4/3 5 minus x cubed to the 1/3 power times a negative 3x squared. Okay. And f prime x will become, notice you have cancellation. So that's negative 4 5 minus x cubed to the 1/3 power times x squared. And so here's how we write this. I'll write it as a final answer. We're going to switch the order. Minus 4x squared cube root of 5 minus x to the 3rd power. Okay, so notice you have that here. Yeah, I'm just going to keep track, right? So remember that you have that constant. This is 5 minus x to the 3rd to the 1/3, and there's an x squared term there. So we just put it together with the 4, negative 4x squared. All right, pretty good. Let's look at the book. Okay. All right, let's find some more derivatives here. So f prime x will be, I'm going to differentiate here. X over x squared plus 1 to the 1/2 power here. Now you look at this and you say, I guess we're going to have to use quotient rule. So QR, quotient rule. Okay. Let's see what this is. So by quotient rule, you take the denominator, x squared plus 1 to the 1/2, and don't forget you actually square that. You bring the denominator up, x squared plus 1 to the 1/2. You differentiate the numerator minus the numerator, and then the derivative of the denominator. All right, double check that this is going on symbolically. Okay. All right. I'm just looking over this. Okay, where are we at? Let me get my, there we go. So let's do some derivatives here. Derivative of x is 1, and I'm going to focus on this one over here. I'm going to color that purple here, right? Okay, so let's actually focus on that since I'm out of space. Maybe I could cut and move. And Atlanta just had a home run. Boo. I wanted a shutout. What inning? 4th. 15-1. Boo. Boo. I wanted 20-0. Okay, let's focus on that derivative. So if we're going to differentiate in purple here, x squared plus 1 to the 1/2. Notice this is power rule. So that's 1/2 x squared plus 1 to the 1/2 minus 1 times the derivative of that x squared plus 1. So 1/2 x squared plus 1 to the minus 1/2. And we differentiate here. That'll be 2x. So this is times 2x. So your 2's cancel. You have x over x squared plus 1 to the now positive 1/2. Because remember, when you have a negative power, it's in the denominator with a positive power. Okay, so we can say up here, replace that with x over, if you want, we'll put square root of x squared plus 1. How's that? We'll put it that way now. And we got to look at this here. I want to remark here, notice this is going to be 1/2 times 2, which is 1. And so let's actually look at the terms here. See what's here. X squared plus 1 to the 1/2 times 1 is itself minus x times this whole thing. So we can say square root x squared plus 1, and then this is going to be minus x times an x over square root of x squared plus 1, everything over an x squared plus 1, I believe. Yeah, because 1/2 times 2 is 1. Okay. All right, and here's what this really is. So we're okay. Square root x squared plus 1 minus x squared over that square root x squared plus 1 over x squared plus 1. Now, you know, people look at this, and I'm going to say it's not as hard to simplify this as you think. Here's what I mean by that. Notice you have this denominator down here, right? So if I'm going to subtract a whole number with a fraction, I need to multiply, by 1. I have to have the same denominator here, okay? So that's kind of nice, because what that means now is I have, if I multiply x squared plus 1 in the numerator over the square root x squared plus 1 minus x squared over the square root x squared plus 1 and everything over x squared plus 1. So if I put this under the same denominator now, x squared plus 1 minus x squared plus 1 over the square root x squared plus 1 over x squared plus 1. These terms cancel. So you have 1 over square root x squared plus 1. And I'm going to say this, I'm going to write this as divided by the x squared plus 1 term. It's a whole number. So you have 1 over square root x squared plus 1 times the reciprocal, 1 over x squared plus 1. So, ladies and gentlemen, here's this derivative here. 1 over x squared plus 1 square root x squared plus 1. Times 1 over x squared plus 1. So the derivative and there you go. So, I mean, there's a lot of functions you can see, ladies and gentlemen. Here's a pretty good one. How about this one here? F of x is sine squared x how about this? F of x is 2 sine x plus sine squared x. Yeah, we'll try that one. So we're going to differentiate. Okay, sine squared x. Now you're going to use properties of derivatives here. So this is 2 dx sine x plus d dx sine squared x. Now, I want to really emphasize the meaning of sine squared x. So that's going to be, let me cut everything here. Sine x squared. Now, the derivative of sine here is cosine. And then I'll say here, I want you to note here, you're going to use the power rule version again. Okay, so let me point out to you this inside. This is the base power. So it's power rule. Base power. Right? So here's my base. So by power rule again for chain rule, here's what we're going to get. This portion here is going to be 2 sine x to the 2 minus 1 times the derivative of sine by chain rule. And what's the derivative of sine? And that's cosine. So keep track. We get 2 sine x. Now that's 2 minus 1. That's 1 times cosine. So we already have a 2 cosine. and that's plus. So your final answer is 2 cosine plus 2 sine x cosine x. We'll keep the ellipse. Okay, how about this one? Your function here, let's say your function here is going to be cosine 3x minus 3 cosine x. Okay. F prime x is dx of cosine 3x minus 3 cosine x. The derivative of a difference is difference of derivatives. Just use your properties. Okay, we got some properties here. Now, this derivative is easy. Derivative of cosine is minus sine. So that one's pretty simple. This derivative, however, we use chain rule. And I want you to note something here. If you have that function we talked about today, cosine of something, chain rule, derivative of cosine is minus sine times the derivative of that inside function here, right? So you got the inside function, 3x. So you can say, is that minus sine of 3x times the derivative of 3x? The answer is yes. And the derivative of 3x, ladies and gentlemen, is 3. So this is what we have all together here, right? Be careful. It's minus sine 3x times 3 minus 3 minus sine x. So everything in gray is the derivative. I'm going to write it down as an answer here. Minus 3, we put the constant first. Minus sine 3x. And then minus the minus makes that plus 3 sine x. Pretty good. Just looking. Oh, I took out Freddie Freeman for some reason. He either got hurt, or Freddie Freeman, sorry. He either got hurt. Something happened. Okay, let's do one more here. I could get back to the game. How about sine squared x minus cosine squared x? F prime d dx of sine squared x minus cosine squared. The derivative of a difference is difference of derivatives. Okay. Now I'm going to do this next step. I guess I'll use it this way. This is sine x to the second power minus put this in the box, cosine x to the second power. Note you have the chain rule version of power rule. This is how you do this question here. Chain rule version of power rule. Base, derivative of that base. Let's look at the power here, 2. Right? So double check, ladies and gentlemen. And actually you have 2 of them here. Cosine to a power. All right, here's what you get. 2 sine x to the 2 minus 1, which is 1, times the derivative of sine, minus 2 cosine x, now the chain part. Don't forget the chain. Times the derivative of cosine. Now, take the derivative of sine. Derivative of sine is cosine. The derivative of cosine is minus sine. So, let's see here. Here's what we're going to get. F prime x will be, keep track of what's really here, 2 sine x times cosine minus 2 cosine x times minus sine x. And maybe it's not ready. Let's keep that in blue for now. Going to be consistent here. So we're going to get 2. You know, one way you can do this, I actually kind of try to do it in alphabetical order, if that makes any sense, because sometimes you can combine these terms and you want to be careful. So, you know, if you got sine x, cosine x, and the other terms are cosine x, sine x. So, you know, if I do it in alphabetical order, it helps me to see the terms that are like, and sure enough, yeah, we can combine these terms. So this will be 4, and again, I keep that in alphabetical order if I can. Cosine x, sine x. Anyway. So, ladies and gentlemen, I did want to give you some extra, derivative questions here. I'm going to upload them for you guys, and I hope you guys find them helpful. And, I'll see you tomorrow here.